Boxplots provide a useful visual display in order to investigate the spread of scores in your dataset, and are particularly useful if you have a large amount of data. They provide information to enable you to make comparisons between the datasets and to see trends. To demonstrate all the components of a boxplot, we'll start with the scores. 20 student scores have been recorded in alphabetical order. These scores have then been placed in descending order and plotted on a chart. As recorded in the table on the right, there are 20 scores which total 1,385 when all added together. The scores have been split into 4 quarters with 5 student scores in each, displayed using different colours. The quarters are split by 3 quartiles. These are the lines that separate the quarters. The lower quartile cuts in at 60.25, which separates the lower 2 quarters. The middle quartile, which is also known as the median, is 69, and the upper quartile is 79. The minimum score is 51, and the maximum is 88. The top 25% of student scores span from the maximum score, which is 88, to the upper quartile, which is 79. This is a 9-score range. The second 25% of students spans from the upper quartile, a score of 79, down to the middle quartile, which is also the median, at 69, a range of 10 score points. The third 25% of students span from the median down to the lower quartile, and the middle 2 quarters that make up the box in a boxplot are called the interquartile range and represent the middle 50% of students. In this example, it spans from the upper quartile at 79 to the lower quartile, 60.25, a range of 18.75. The fourth quarter, the lower 25% of student scores, range from the lower quartile to the minimum score. The mean, which is a measure of central tendency along with the median and mode, sometimes also known as the average, is the total sum of all scores divided by the count. There is a nice even distribution of scores across each of the quarters, and the mean and the median are at approximately the same point. You should always be aware of the scale on a chart. This example only displays a range of 45 to 90, and as with all charts, it is important to be aware of the sample size, which is the number of students being represented. A small sample size can make it difficult to make accurate conclusions due to the variability associated with it. In this next example, the scores for 20 students have been plotted against the chart, but their scores are not so evenly distributed. Again, the scores have been split into 4 sections with 5 students in each. Let's now investigate the range of scores in the quartiles. Student results in the top quarter spans a range of 8 score points. In the second top quarter, a range of 13 score points, and then 12 and 41 score points for the lower 2 quarters. You can see from the display that the concentration of student scores in the top 3 quarters pushes the distribution towards the upper range of scores. The uneven distribution of results is also reflected in the mean being considerably lower than the median. A distribution such as this should lead to inquiry about the context in which the assessment was undertaken, as well as pedagogical practices that may have influenced these results. In this example, again with a sample of 20 students, the distribution of scores is varied in each of the quarters. Unlike the previous example, the range of scores in the top 25% is large compared to each quarter in the lower 75% of the distribution. This also raises questions for the teacher in terms of the context in which the assessment was undertaken and the influencing pedagogical practices.